All right, we have a boat that's going upstream on the river and averages 5 miles per hour. Going downstream, the boat averages 9 miles per hour. We need to find the speed of the current and the speed of the boat in still water. Okay? So the way I like to solve this problem is by doing distance equals rate times time. We need to use that formula. So distance equals rate times time. And what we're going to do is we're going to set up a table. Now if you notice, we have two trips. We have one trip downstream and we have one trip upstream. So upstream and downstream. Now this one, it doesn't straight out say, okay, your distance is this and your time is this. We have to kind of find it. Well, if when we're going upstream, it averages 5 miles per hour, that gives us enough information to put in a time and a distance. We can say, okay, we know when we're going upstream, we're going to go 5 miles in 1 hour. Now, when we're going, actually, let's go ahead and finish this. Now, when we're going upstream, we're going to have the rate of the boat, but think about trying to go upstream. I don't know if you've ever paddled in a boat. When you're going upstream, you're going against the current, and so it makes sense that you'd be going slower. And so you need to subtract the current because it's going to slow you down. Now downstream, it's nice to go downstream, isn't it? So it goes 9 miles per hour, so we'll go 9 miles in 1 hour. Now this time we're going to have the rate of the boat, but this time I'm sure you've experienced this too. When you're going downstream or floating downstream, you go a lot faster. There's no resistance, and that current pushes you, makes you go a little faster, and so we would add in the current. Okay? So we've got our two upstream downstream trips, and now we're going to set them up in an equation just using this distance equals rate times time formula. So let's go ahead and write it out. We have distance, which is 5, equals our rate, which is r minus c. I'm going to put that in parentheses because I want the entire rate times the time. Okay, similarly with the bottom one, we have 9 equals r plus c, again times 1. What's awesome, when we're multiplying by 1, it's just going to state itself, and so we'll have 5 equals r minus c, and 9 equals r plus c. Okay, so we've got ourselves a system of equations, and so we're going to solve it. We could solve it by substitution. In this case, I would recommend using the elimination or addition method because we've got these c's that have coefficients that are the same but opposite. So it's like we've got a -1 and a +1, so that when we add these two together, we're going to have those cancel out. So -1 plus 1 is just going to be 0. Okay, but let's start from the left. So 5 plus 9, we get 14. Equals r plus r. You could put a 1 here if that makes you more comfortable. So 1r plus 1r, we get 2r, and the c's canceled each other out. We divide by 2 to solve for r, so 7 equals r. So the rate of the boat is 7, and that's something you'll want to write. So the rate of the boat. Now we need to find the current. Well, according to this, we know that r plus c equals 9, right? We found that equation. And so we can plug in r, or 7 for r, so we get 7 plus c equals 9. And then we just go ahead and solve for c. So c equals 2. So the current then equals 2 miles per hour. Oops. And we can also put that here, miles per hour. And this is something you might want to check. Let's make sure it works. So if I do 7 minus 2, I'm going to get the 5 miles per hour for going downstream. If I get 7 plus 2, I'm going to get the 9 miles per hour for, I might have said that backwards, the 9 miles per hour for downstream, the 5 miles per hour for upstream. So in conclusion, when you're doing these types of problems, I would highly recommend setting up a table using the distance equals rate times time formula. Fill out the table and then use that table to help you set up equations so you can solve as shown. If you're still feeling confused, please reach out.